Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture, I am going to explain questions on reactivity of alkane for chlorination and bromination. These are the questions. First, note down some important points on this topic. Halogenation of alkane is a substitution reaction. In this reaction, halogen replaces one or more hydrogens of hydrocarbon. This is hydrocarbon. So here substitution is taking place. Reaction takes place by treating alkane with a suitable halogen in presence of either ultraviolet light or by heating to around 520 to 670 Kelvin. Reactivity order for halogens, this one. Fluorine is most reactive, then chlorine, then bromine and then iodine. So reactivity is decreasing in this direction. Reaction mechanism is free radical in nature. Mechanism is having 3 steps. First step is chain initiation. What is happening here? Halogen molecule takes up energy either from UV light or from heat. And what will happen? Homolysis or homolytic cleavage takes place here. By homolysis, we will get X dot plus X dot. Next step is chain propagation. Suppose we are taking methane molecule. So this covalent bond you can represent like this, because one covalent bond is formed by sharing of 2 electrons. Now this X dot is in the medium. One dot will come here and H dot will come here to form this methyl free radical plus HX. Then this methyl free radical reacts with another molecule of halogen. One X dot will come here, another dot will come on X to form this substitution product. This is mono-substituted product. Like this way you can get di, tri, tetra substituted product. All those I am not showing here. And the last step is chain termination. In chain termination step, 2 free radicals combine to form different products. 2 X dot can combine to form halogen molecule. Methyl free radical means alkyl free radical can combine with X dot to form haloalkane, or 2 methyl free radicals can combine to form ethane. Main thing on this topic is that you have to remember reaction takes place via free radical, carbon free radical. Now halogenation of higher alkanes gives mixture of isomeric products. On a particular hydrocarbon, hydrogens may be tertiary, secondary, primary. Reactivity order of hydrogen where substitution of halogen can take place is this one. Tertiary hydrogen is most reactive, then secondary and then primary hydrogen. This is important point you have to remember. Now for chlorination, the relative abstraction rate of 1 degree hydrogen, 2 degree hydrogen and 3 degree hydrogen are in the ratio 1:3.8:5. Means which hydrogen will be abstracted more rapidly, tertiary, secondary or primary. This is the rate ratio. And for bromination, this rate is 1:82 is to 1600. Means tertiary hydrogen will be brominated much more rapidly than secondary hydrogen, and secondary hydrogen is brominated much more rapidly than primary hydrogen. So these two things you have to remember. So first question, 1-halo-2,3-dimethyl butane will be obtained in beta yield if halogen is. So first draw the structure of this compound. CH3, CH, CH. 1 halo means at this position halogen, here 1 methyl, here 1 methyl. So to get this halo derivative, what should be the parent hydrocarbon? In place of X put hydrogen. So this is the parent hydrocarbon. In place of X put H. So this will be CH2 and H means CH3. So what halogen here we have to use so that in presence of UV light or heat we will get halo substituted product. Now note down one thing. We have seen the reactivity order for halogens are this one. Fluorine is most reactive, then chlorine, then bromine, then iodine. So this is more reactive than bromine. So note down, the more reactive the reagent, the less selectively it attacks. Chlorine is much more reactive than bromine. So for that reagent which is more reactive, selectivity is less for that because it will go and attack at random. That means a reactive reagent attacks both reactive and unreactive site of the molecule. We know that reactivity order of tertiary hydrogen is more than secondary, and secondary is more reactive than this. But for chlorine, which is very reactive reagent, their selectivity will not be there. At random it can attack. So in this compound, this hydrogen is 1 degree, this hydrogen is 1 degree, this hydrogen 1 degree, this hydrogen 1 degree, and this hydrogen is tertiary and this hydrogen is tertiary. In the product, 1 degree hydrogen is substituted by halogen. This product in beta yield only we can get if here we will use this more reactive reagent because it will be less selective and here it can attack to give better yield of this compound. If bromine you use here, bromine is less reactive, so this is more selective. So here what will happen? It attacks this tertiary center more. For that you will get this type of product, CH3, CBr, this thing as major product for monobromination. So here option A is your answer. Now for this question, this is your starting hydrocarbon. So in this compound, this is primary hydrogen, this hydrogen is tertiary hydrogen because this carbon is bonded to 3 carbon atoms. The less reactive the reagent, like bromine, the more selectively it attacks a position. More selectively it attacks that position which is most reactive. So here tertiary, this hydrogen is most reactive, so that will be substituted by X. That means that option B is your answer. If you take here bromine, then less reactive, more selective reagent attacks here at the most reactive site, and this one you will get as major product. Next question. Now see, this is isobutane. If you treat isobutane with chlorine in presence of UV light, what is the major product? Now see, here two types of hydrogens are there. These 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 hydrogens are primary hydrogens, and this hydrogen is tertiary. This is tertiary, these are primary. Now see, if you treat this with chlorine H nu, so what are the different products? A mixture of product you will get. So these 9 hydrogens are equivalent. So for monohalogenation, this is one product you can write, and this is another type of hydrogen, tertiary. So this hydrogen will be replaced by chlorine. So two different types of product you can write. Now which one will be the major product? We have studied already for chlorination the relative abstraction rate for 1 degree hydrogen, 2 degree hydrogen and 3 degree means tertiary hydrogen by Cl radical is 1:3.8:5. That one you have to remember. Another thing you have to remember, reactivity of any hydrogen atom is proportional to number of hydrogen atoms of that kind into reactivity of that hydrogen. This is reactivity rate. This thing also you have to remember. Reactivity of any hydrogen is proportional to number of hydrogen atom of that kind into reactivity of that hydrogen. Now mark, this is product 1, this is product 2. Now see, two types of products are there. So product 1, product 2. Here kind of hydrogen for product 1 we will get from 1 degree and product 2 we will get from tertiary hydrogen. So number of hydrogen, 1 degree hydrogens are 3, 6, 9, total 9. Here number of tertiary hydrogens 1, here relative rate 5. Reactivity of primary hydrogen is number of primary hydrogen into its rate. And for tertiary hydrogen, reactivity is 1 into 5. Means this. So total reactivity means you have to add up all. Total reactivity. 9 plus 5 means 14. Now relative proportion. Relative proportion of product 1 is, how you will get it? Here for product 1 reactivity is 9 and total reactivity is 14. So this divided by this you have to do. Then percentage yield of product 1, how you will get? You have to multiply it with 100. You will get approximately 64%. For product 2, relative proportion, how you will get? Product 2 means this one 5, reactivity is 5 divided by total reactivity and percentage yield. Here you have to multiply with 100 so that approximately you will get 36%. So which one is major? 64 is more than 36. So product 1 is major. So this is your major product. That means here which product you will get? This product you will get. For chlorination, always you have to use this formula and you have to calculate which is the major product. But for bromination, bromine is less reactive, more selective. So more reactive hydrogen will be reacted there for bromination. Hope it's clear to you. If you like, please subscribe. Thank you for watching.